If you are an American born today, you are on a direct trajectory towards having a blood sugar problem, having metabolic dysfunction, and having insulin resistance. And this will increase your risk for almost every chronic disease. It will decrease your health and happiness and will cause you to die earlier.
Why is it so important we look at and manage our blood sugar levels?
Blood sugar is such an incredible readout of so many aspects of our health. So many things go into it. Of course, the food we eat, but also things like how much we sleep every night and the amount and type of exercise we're getting, how much stress we're under, what's going on with our microbiome, what kind of environmental toxins are we exposed to, and even actually something like how much sunlight we're getting. All of these factors translate biochemically in our bodies to how our metabolism is working. And blood sugar is essentially a readout of our metabolism. And it's really the best thing we have right now to track how our lifestyle factors are turning into fundamental health in our bodies. So when blood sugar is stable and in a low and healthy range and not spiking all the time, going way up and then way down and way up and way down, that's really one of the greatest life hacks that we have for being psychologically and emotionally stable throughout the day. When we have those big spikes and crashes, it can really it can translate into lability and how we're feeling. We might feel really tired after a big blood glucose spike and crash. We might feel a little bit more anxious. We might feel some brain fog after that spike and crash. So stability in our blood sugar actually can translate to stability in our day, and that's really just in the short term that we see those benefits. Over the long term, having more stable glucose levels in a healthy range is really an unlock for longevity and prevention of chronic disease, because we know that big swings and crashes in our blood sugar throughout the course of our lifetime, which is called glycemic variability, is an independent risk factor for heart disease, stroke, and type 2 diabetes. So we want to keep that large glycemic variability much tighter. And we can do that by understanding our diet and understanding which foods we're eating and how we're eating them are leading to blood sugar spikes, and then modulate to move things from very spiky to more stable. And we can also dial in those other lifestyle pillars like sleep and exercise and stress management to really optimize how our blood sugar dynamics are happening throughout the day. So if we want optimal longevity, we really need to have our blood sugar under control. That's just table stakes. And so this is one of the reasons why learning how to eat properly for stable blood sugar in our younger years is such an important unlock for prevention of chronic disease and longevity in the future.
Well, you talked about it a little bit, but I want to get into the physiology of, on a short-term basis, you mentioned how it might affect how we're feeling. And on a long-term basis, if we have those spikes going up and down chronically, it can lead to these chronic health issues. But let's talk acutely and chronically, the specific physiology and what's happening in the body when that blood sugar is just going up and down, up and down.
Absolutely. There's 5 main things to think about when we're thinking about blood sugar spikes. The first is that a big acute blood sugar spike can actually lead to inflammation in the body, which we know is related to so many chronic diseases. Chronic inflammation is really a root cause of so many of the chronic diseases we're seeing today. So a big spike in the body says to the body, oh, something's a little off here. Our homeostasis is a little bit perturbed at the moment, and that's a threat signal. So the body will actually mobilize an inflammatory response to a large glucose spike. We don't want that day in and day out for the course of our lifetimes. And of course, the average American, day in and day out, is eating refined carbohydrates and sugars, and is on that blood sugar roller coaster. So inflammation is number 1. Number 2 is oxidative stress. So this is the generation of damaging metabolic byproducts called reactive oxygen species, which when they are out of balance, when the body can't handle how many of these reactive molecules are being generated, they can go around and damage the cell. They can damage fats and proteins and DNA and cell membranes and cause dysfunction in the body. So we don't want excess oxidative stress, and big swings in glucose basically drives more of these metabolic chemical reactions in the body and can generate more of these metabolic byproducts in excess. The third is glycation. So glycation is actually just when concentration of glucose in the blood is high, more glucose will stick to things. It will glycate things. So also it will glycate things like fats, protein's DNA. And when you have sugar stuck to something, not ideal. And an example of this actually is wrinkles. Wrinkles are the result of glycation, in part because high sugar binds to collagen, one of the most abundant proteins in the entire body, which makes up a lot of our skin. And when sugar binds to the collagen, it glycates the collagen, and then the collagen basically forms cross-linking. And so it's a little bit more of a jumbled mess in the skin and contributes to wrinkles. The fourth problem is that a big blood sugar spike is often going to be followed by a big crash. And that process is called reactive hypoglycemia. And if you have a much more gentle rise after a meal, you're not going to see that big crash, because when the body gets a big blood sugar spike from a large carbohydrate-rich meal, the body responds by releasing this hormone called insulin from the pancreas. And that's the hormone that, of course, allows you to take blood sugar out of the bloodstream and into the cells. And if you have a really large blood sugar spike, you're going to have a large insulin surge. And that can sometimes overshoot in taking up glucose out of the bloodstream and lead to this dip after the meal that's actually lower than your pre-meal baseline. And that dip is often when people feel that anxiety, fatigue, needing that second cup of coffee, and more cravings. We've seen that in that reactive hypoglycemia moment, that's when people reach for more sugar, in part probably because they're trying to get their blood sugar back up. So we can avoid that by just keeping things more stable. And then the fifth thing that's really important to focus on is that these spikes over the long term are going to generate what's called insulin resistance. Because if you're constantly spiking your glucose and therefore spiking your insulin, the cells are overwhelmed with this insulin signal. And when cells in the body are overwhelmed by a chemical signal, they often will respond by down-regulating the ability to respond to that signal. So they'll make the receptors less sensitive to that signal to kind of protect the cell from all of this influx. So the cell is saying, you're driving so much sugar into me, my mitochondria, the energy factors of the cell that actually convert the glucose to energy, they're overwhelmed, too much reactive oxygen species are being created, we need to block some of this entry into the cell. And that's called insulin resistance. But the body is like, no, we got to get this blood sugar out of the bloodstream. So it actually responds by surging way more insulin to drive the blood sugar into the cells. So you've got this kind of ratcheting up of more glucose spikes, more insulin resistance, more insulin being secreted, a process called hyperinsulinemia. And this insulin resistance is, of course, at the root of type 2 diabetes. But we also now are learning that insulin resistance is related to 9 of the 10 leading causes of death in the United States. Insulin resistance is a big deal. It's a big problem. And now most Americans have it because of the way that we're eating and living. So we want to stop constantly stimulating the body with these large swings in glucose to kind of take the gas off how much insulin we're having to secrete every day, give ourselves a little bit of a break from having to respond to all of this, keep them insulin sensitive. And the reason insulin resistance is so damaging is because aside from insulin having that effect of helping take glucose out of the bloodstream, it has dozens and dozens of other biologic effects. So when it goes up with hyperinsulinemia, it's having effects on the whole body. Some things that it does that we don't want. One, it is actually a fat storage hormone. It's an anabolic hormone. And you might wonder, well, why is that? Well, because fat and glucose are 2 of the main substrates for energy in the body. And if you've got tons of glucose coming in and the body understands that as a high insulin level, then it's going to say, oh, well, we don't need to use fat for energy because we've got so much glucose around right now. So it will stop fat burning and it will promote fat storage because you've got so much glucose. So for the 74% of American adults who are dealing with overweight or obesity, this is obviously very relevant. We don't want insulin levels to be high. The second thing is that because it's an anabolic pro-growth hormone, it can do things like stimulate the growth of cancers. So we don't want that. We don't want to be pushing growth all the time. It has effects on nearly every cell type in the body. So just another example, it stimulates the ovaries to make testosterone. So strangely enough, the leading cause of infertility in the country right now is polycystic ovarian syndrome. And the root cause of what's going on in this condition is that high insulin levels stimulate a cell type in the ovary called the theca cells to produce more testosterone and androgen hormones than it's supposed to. And that is really the root cause of why we see the fertility and menstrual regularity issues and some of the other symptoms like excess hair growth and acne. And a last example, there are literally dozens of these of how it's a root cause of so many chronic diseases, but it also negatively impacts the ability of the body to synthesize a compound called nitric oxide, which is a key compound that helps dilate our blood vessels. So when your insulin is high, you're going to have more trouble dilating your blood vessels. And really, one of the foundations of health is, can we get blood to a tissue type? Like, we need to get blood to every single cell type so that it can actually do its work and have the oxygen it needs to do aerobic respiration, metabolism. And so we see so many diseases now that are an issue with cell types not getting enough blood sugar. Anything that's like a small vessel or a large vessel disease. So retinopathy, small vessels of the retina having problems. We see this in people with diabetes. Erectile dysfunction, the penis not getting enough blood. We see this in high rates in people with diabetes. Heart attack, stroke, two of the leading causes of death in the United States. Kidney disease, where the small vessels of the glomeruli in the kidney don't get enough blood. So anytime we're not making nitric oxide, which is directly related to excess insulin and insulin resistance, that's a problem. And so that fifth reason of insulin resistance is, aside from inflammation, glycation, oxidative stress, reactive hypoglycemia, and insulin resistance, this is really the reason why we do not want to be spiking our glucose all the time and putting this huge strain on our body. We want to stay as stable as possible as we can throughout our lifetime in terms of our glucose levels.
So what I'm hearing you say here is there's this intimate relationship between glucose and insulin, and basically our control over both of these, at least in a certain way, is to regulate our blood glucose, which is going to spike insulin when that rises. So our entry point to having an influence on both of these is our blood glucose.
It is. And I will definitely caveat that by saying it's one of them. There are many other things that go into optimal insulin sensitivity aside from just how much we're spiking our glucose. For instance, when we get one poor night of sleep, it directly impacts our insulin sensitivity. When we do one high intensity interval training workout, it directly positively impacts our insulin sensitivity. So there's lots of elements of the body's physiology outside of just what we're eating and how it's spiking our glucose levels that can impact our insulin sensitivity. And so there's really a holistic framework for it, but glucose is definitely one of the lowest hanging fruit ways to just take the pedal off how much insulin is having to be secreted. And another one that's really important to realize is that while glucose is a predominant sugar that we're eating right now, and we're eating it in such wild excess compared to what we were eating probably 100 years ago and for the rest of evolutionary history, our diets have changed monumentally over the last 100 years with industrialized food. And most research suggests that we're eating around 50 to 150 pounds of added sugar per year. It's hard to even fathom. Probably 100, 200 years ago, we were eating less than about a pound a year. And so this is just like such a strain on our biologic machinery. But the other thing that's really important to think about is fructose. So another sugar that's not glucose, and sucrose, which is table sugar, which is also the sugar that's added to most processed foods, is a combination of glucose and fructose. But fructose has a really interesting effect as well, because fructose, if you eat straight fructose, it will not spike your glucose levels. You will not see it, for instance, on a finger prick glucometer. You will not see it on a continuous glucose monitor. However, it is going to lead to insulin resistance and therefore feed into glucose instability. And the reason for that is because it's pretty fascinating. Fructose, when it's broken down in the body, generates a byproduct called uric acid. And uric acid in excess in the liver, fructose is broken down in the liver, that uric acid can damage the mitochondria, these energy producing factories in our cell. And when the mitochondria aren't working properly, instead of converting glucose to energy, the energy is called ATP that we're trying to ultimately generate through fat or glucose breakdown, the mitochondria do that. And when that process is somewhat broken, the glucose to ATP pathway, it's going to signal for the body to stop moving through glucose through that pathway and to actually store these extra calories as fat. So now we start generating fat in the liver. And the liver is intimately connected to the pancreas, the organ that produces insulin. And so if the liver is screwed up and the cells are all clogged with fat and the liver is becoming insulin resistant because of this excess fat generated through fructose breakdown and the impact of uric acid, the pancreas is saying, oh gosh, the liver is not responding to our signal. We've got to really increase that signal. So it starts surging out more insulin. So really this liver, pancreas, liver fat connection is a big root cause of why we might get hyperinsulinemia and insulin resistance. So it's interesting that this is like a totally glucose independent pathway of sort of screwing up the same system. And so to answer your question, yes, glucose is one of the key ways that we can kind of take the gas off that process. But there's many other elements involved too, like fructose and sleep, and exercise and even stress, which actually makes us insulin resistant. The microbiome is also intimately integrated in this because the microbiome make metabolic byproducts like short chain fatty acids that keep us metabolically efficient and insulin sensitive. So we've got to think about the holistic framework. But in terms of the simplest things that we can do, lowering our sugar consumption and figuring out how to decrease the glucose spikes that result from our meals by doing thoughtful things like pairing high carbohydrate foods with protein and fat and fiber, which will blunt the glucose spike, basically gives our body a little bit of a rest from this constant blood sugar roller coaster that we're on.
You've talked about insulin resistance there a couple times, and a piece of it I think that's important for us to talk about is the fact that insulin resistance can be affecting us in the background for a period of time before we see it in the blood glucose. A lot of doctors are going to test fasting blood glucose in the morning and see where that's at, but even if that is in a normal range, that person could be building up insulin resistance over the years, which that increased insulin is going to keep the blood glucose down. But as we've talked about, insulin is one of the enemies and blood glucose, which have this intimate relationship, but they need to be looked at separately.
Yeah. So one takeaway I would say to everyone listening to this is go ask your doctor for a fasting insulin test. And this is for the exact reason that you just mentioned, Jesse, which is that insulin problems and insulin resistance can show up well over a decade before our standard lab tests like fasting glucose will start to have problems. And this is because of what we talked about. The body has this incredible adaptive capability of essentially overcompensating for a problem for a long time before the system really breaks and we really go off the rails. But in that intermediate period where insulin resistance is going up, insulin levels are going up, but glucose is still staying the same in the bloodstream because the body's essentially overcompensating to overwhelm the insulin resistance and still get the glucose taken up out of the bloodstream. That period we are missing in Americans right now. And that's a big problem because we're missing the pre-disease state, the pre-overt disease state where there's already cellular dysfunction that is having a hugely negative impact on our health. So one thing that you can do to look into this is to get a fasting insulin test and see if it's starting to go up. We want it to really be between about 2 and 6 on our lab slip. The standard ranges will say anything under 25 is normal, which if your fasting insulin is 25, that's a big problem. That's hyperinsulinemia. So really shooting for an optimal range around 2 to 6 is really optimal. And then you can also, if you get a fasting glucose test at the exact same time as your fasting insulin test in the same blood draw, you can just go online and there's actually a calculator for insulin sensitivity called HOMA-IR. And you can plug in your glucose and insulin and it basically uses a mathematical equation to give you a readout of insulin sensitivity. And there's other things that you can do. Let's say your doctor won't order a fasting insulin test for you because it's not standard of care. We don't do this normally, which is very, very strange. What you can do is just look at your standard cholesterol panel. And on the standard cholesterol panel, you're going to see four different types of cholesterol. So you're going to see total cholesterol, HDL cholesterol, LDL cholesterol, and triglycerides. And interestingly, you can take a ratio of two of those numbers, triglycerides, and divide it by HDL. So do a triglyceride to HDL ratio, and that can actually give you a clue about your insulin sensitivity. And so that's kind of just like a little simple way that you can get a sense of it. And what we really want to see is that for people, there's not a consensus of exactly what this number should be for optimal health, because we don't really think that much about insulin sensitivity, unfortunately, in our current healthcare system. But if you look at kind of what experts say, it actually seems like it may be in part ethnicity dependent, and that for people who are Caucasians, you want to be below about 2.5 to 1 on the ratio, and for people of African American descent, a little bit of a tighter ratio of 1.5 to 1. So let's say your triglycerides are 100 and your HDL is 50, that would be a ratio of 1.5 to 1. I think, if I did the math right. And so I'm really actually shooting for 1. So that would be like a triglyceride of 70 and an HDL of 70. And triglycerides are the part of the cholesterol panel that really tells us about how glucose and carbohydrates are being converted to fat in the bloodstream. And so you're looking at essentially a ratio of the amount of cholesterol in the bloodstream that's sort of related to excess carbohydrates over HDL, which is our good cholesterol that brings it's the type of cholesterol that goes back to the liver and clears cholesterol from the bloodstream. So that's kind of what you're looking at. So fasting insulin is a great test, and triglyceride HDL is something that all of us can look at if we have a standard cholesterol panel. So insulin sensitivity is something we should all know about in our own bodies, and unfortunately, it's something we have to advocate for on our own because it's not standard of care to test these things.
Yeah, that's something I want to get a little bit deeper into. The fact that doctors aren't necessarily testing for these things, and a lot of people might not, have a CGM and be monitoring or doing a prick of the finger and seeing where their blood glucose is. So basically what I'm getting at here is, how common is this, and how many people are actually aware that there is a problem?
The numbers are absolutely staggering. Currently in the United States, I can't speak to Canada, unfortunately, I don't know the exact numbers, but in the United States, 128 million Americans have prediabetes or type 2 diabetes. So this is half of American adults. And prediabetes and type 2 diabetes are overt insulin resistance. This does not account for any of the people who are in the pre-prediabetes state, who are in that window of probably developing insulin resistance, but their glucose numbers haven't hit the threshold where we're going to actually diagnose them. So half the country has a largely preventable blood sugar issue. That is monumental. And that blood sugar issue, as I mentioned, is driving 9 of the 10 leading causes of death in the United States. They're all linked by metabolic dysfunction, of which blood sugar is one of the readouts, either causing the cause of death or accelerating it. So that's incredible. There's other statistics that are kind of worth noting. There was a recent study out of UNC that showed that 88% of American adults have at least one biomarker of metabolic dysfunction. So they might not have overt prediabetes or type 2 diabetes yet, but they have one biomarker that shows there's something sort of going wrong with this energy production pathway of the body. And that is looking at the 5 criteria of metabolic syndrome, which takes into account blood pressure, cholesterol levels, fasting glucose, and waist circumference. And so basically, if you had one of those that was not optimal, that encompassed 88% of the country. So only 12% of people had all 5 of the biomarkers in perfect range without medication. And I will say, those criteria for metabolic syndrome are fairly lenient. Like, for instance, telling people to have triglyceride or fasting glucose under 100, that's all totally fine. But we actually know that fasting glucose up towards 100, you're already at increased risk for problems. And so these ranges were even lenient. So I bet the number is even more than 88%, but that's still staggering. It should be that almost everyone has all those 5 biomarkers perfect. If you have a diet and a lifestyle that's really dialed in, it's not that hard to keep those in good range. And so 88% of American adults have at least one biomarker of metabolic dysfunction. Other things worth noting. So right now, 30 to 40% of US adults have fatty liver disease, non-alcoholic fatty liver disease. And this gets back to what we were talking about with the liver fat being generated because of mitochondrial dysfunction in the liver, which is caused by what we're eating and how we're living. So this is 30 to 40% of people having true organ dysfunction that's driving insulin resistance that is completely driven by processed food and sedentary behavior lifestyle. It used to be that alcoholism was the reason that we had fatty liver disease, but the non-alcoholic fatty liver disease has far outpaced alcoholic fatty liver disease now as one of the leading causes of chronic liver disease in the country. And shockingly, 10% of children now have fatty liver disease. And it's not really that hard to imagine that that's happening given the huge hordes of excess fructose that kids are eating in their packaged foods, their cereals, their sodas, and their juice. And I actually think the number is probably much, much higher than that because, of course, we're not screening every child for liver enzymes and doing ultrasounds of their livers and things like that. But given obesity rates in kids, it's probably quite a bit higher. So that's really just an organ manifestation of this underlying insulin resistance problem. So if you are an American born today, you are on a direct trajectory towards having a blood sugar problem, having metabolic dysfunction, and having insulin resistance. And this will increase your risk for almost every chronic disease. It will decrease your health and happiness and will cause you to die earlier. And so this is something that we just all want to get on top of. And unfortunately, the medical system is doing a abjectly terrible job at managing this. We are very reactive. We are not proactive at helping people get at these issues. We focus on pharmaceutical approaches almost entirely to these problems and not thoughtful dietary and lifestyle practices. And we as Americans are really left to our own defenses to figure this out, which is in part why I think we're seeing a real grassroots movement towards interest in metabolic health, because the healthcare system is not doing a great job. And there was actually a fascinating paper that came out, it was either early this year or late last year, and it was a study looking at 21,000 individuals who are eligible for glucose screening. And of the people who had elevated glucose in the pre-diabetic range, zero people got the appropriate treatment for prediabetes. 21,000 people in this study. Zero people got appropriate treatment for prediabetes. So this is, I mean, how is this not front page news? Doctors don't even know how to treat this, identify it, and we can hopefully link that paper in the show notes. I mean, it's just an embarrassment. And the healthcare system is really going through a crisis right now because what we're seeing is that costs are going up. We're now spending $3.8 trillion a year on healthcare, and outcomes are getting worse. Costs going up, outcomes getting worse. In any other industry, this would be like a red alarm. This is not acceptable. This is the definition of unsustainability. And so we're all just going through the motions, continuing things as the status quo, driving more money into the system, seeing life expectancy going down. We're seeing people get sicker. We're seeing people get fatter. We're seeing people get more depressed in our country, despite throwing more money at it. So if you're a doctor, if you're a practitioner, and you're seeing this trend happening, my question to you is, what are you doing? Like, this is when you stop and you step back and you say, why? That's our responsibility. And so that's really what drove me out of the conventional healthcare system and into trying to empower people with their own health information. Because, if you just pop up and look at what's really happening, it's really a disaster. And I think a lot of this is because we have looked at all these diseases that we're dealing with in the United States, all the leading causes of death, things like stroke, heart disease, diabetes, chronic liver disease, chronic kidney disease, cancer. We've said, oh, well, they're all different diseases. They're in different organs. They have different symptoms, so they're different. But in the last 10, 15, 20 years, as we've really understood more about the true physiologic nature of disease and what actually leads to disease and can actually categorize diseases based on what's causing them, not just what their symptoms are, we're starting to realize that these diseases are all linked by the same core physiology. Things like insulin resistance, things like chronic inflammation, things like oxidative stress. There's these core pathways that link diseases. And yet we haven't started treating at that level. We're still treating diseases as these siloed, separate entities where success looks like symptoms maybe going away or symptoms being reduced. But that symptom management approach does nothing to change the core physiology of what's leading disease, which is why we're not seeing good outcomes. So we need doctors to wake up to this, to read the more recent literature in systems and network biology, looking at the network of diseases and not just the symptoms-based approaches to diseases, and to wake up and say, we're going to treat at that level. We're going to treat at the root cause of what's causing disease. And the interesting thing is the only way to really change these core pathways like inflammation and insulin resistance fundamentally is through what we eat and what we do every single day. The thousands of micro decisions we make every single day that translate into our biologic reality. When you think about the complexity of cellular biology and that these core pathways in the cells are leading to so many of these different, just seemingly disparate diseases, it really becomes obvious that there's no one small molecule that's going to fix this whole system. The way we fix this system is we build a body that functions properly. And we build a body that functions properly by what we're putting in the body every single day and what we're exposing it to every day. So that's the challenge for doctors. That's the challenge for patients, is how do we build a healthy body? And that's where all the different diet and lifestyle pillars come in. So that's just kind of a long-winded way of saying that these issues are monumental. We've all got to be aware of them, and the healthcare system really needs to shift. And I think it's going to have to shift starting with individuals and patients, because the healthcare system is deeply incentivized to not solve these issues because we get paid on volume. We get paid by the more patients we see. So a healthy patient is no longer a customer. And so it really, and I'm not knocking the healthcare. I think doctors are wonderful people with great intentions, but incentives matter. And unfortunately, our business model and our incentives are really problematic for keeping people entrenched in the system that promotes reactivity and promotes getting people in your office. So that's kind of the big picture take on what's happening. And I think just the last thing I'll say is going back to the numbers, of people with prediabetes, which is about 90 million Americans, of that 128 million Americans that I talked about with prediabetes or type 2 diabetes, 90% of the people with prediabetes don't know they have it. So they're going to the doctor every year and somehow they're not getting that information. And so you need to get on top of this for yourself. Look at your blood sugar test, look online, see what the ranges are, and find out if this is a problem. And then advocate for yourself to get the help you need to get this under control, which, of course, diet and lifestyle are our primary levers to do that.
For somebody who's listening right now and saying, oh, this sounds so terrible, everything's a wreck and I can't really see the light here, I want to highlight, and you've touched on this, the fact that the good news in all of this is that it is in our hands. This is, if you're not too far down the rabbit hole, this is a correctable problem, and it's something that you can actually take on yourself through diet and through these different lifestyle factors. And overall, it's not going to be that expensive, so it's manageable for most people. So there is a positive light given all those statistics, if we can get the education out there, and if people can start to take control of their own health, because unfortunately, like you said, it's not going to happen from the top down. It's going to take people on a grassroots level learning about this and taking a stand for themselves.
Definitely. There's nothing but hope in the realm of chronic disease and metabolic health, because the body is a regenerative machine. If you give the body the right conditions, and conditions are created by what we're eating and how we're living, it will absolutely adjust and course correct. Even if you are far down the pathway of dysfunction, severe obesity, type 2 diabetes, heart disease, heart disease plaques can reverse. Not something we learned in medical school, but lots of research suggests that even, hard atherosclerotic plaques can regress with the right conditions. So what we have the control over those conditions. And, I really think it's important for people to realize that, that food is one of the best levers we have to control our destiny. We eat about 1 metric ton of food per year. We eat about 2 to 3 pounds of food per day. And what is food? It's like sometimes we, think it's for pleasure, it's for community, it's for energy, whatnot. But what food is food is molecular information. Food is the substrate of what builds our bodies, builds our cells. We are shapeshifters. We're constantly turning over. We have hundreds of millions of cells that die every day that we're regenerating. We have 37 trillion cells total, and they're constantly turning over. And the food is what helps us rebuild these things. And so if you're putting the good stuff in, you're building a better structure, and a better structure will function better. But aside from being the substrate for our bodies, it's also the chemical signaling information that tells our bodies what to do. It activates or turns down genetic programs. It changes the folding of our genes. Food molecules like micronutrients, like zinc and manganese and magnesium and vitamin C, these things are going into our cells, going into our mitochondria, and acting as the lock and key cofactors that allow enzymes and proteins to do their metabolic work. So food is just this incredible lever that we have to control our biologic and genetic destiny. And I think that's really, really empowering. And then, of course, all these other things that we can dial into, like getting more quality, quantity, and consistent sleep, making sure we're moving, at least 150 minutes a week of moderate aerobic activity or 75 minutes of vigorous aerobic activity, making sure that we're doing strength training at least a couple times a week. Even just walking after our meals to help clear some of the blood sugar. Movement is this incredible lever that changes our biochemical reality and can really improve our mitochondrial function, our metabolic health. And then stress, stress management is one that I think really gets overlooked. And something fascinating about stress is that you ask a patient when they come into the office, are you stressed? And like 90% of the time, people will be like, oh no, I'm not stressed. Like, I don't have that much stress. But then you start talking to them about their lives, and it's like, everyone's under stress. Like living in the modern Western world is inherently stressful to our physiology. And it's honestly just become our new normal to be chronically stressed. The emails are coming in, the phone is buzzing. We've got blue light coming in all the time, 24 hours a day, which totally confuses our body and is a stress signal. We've got honking. Like these things translate into stress physiology in our body. And the body's really interesting in its relationship with stress and metabolism, because it used to be that if we were under stress, like historically, there probably was a physical threat, like we had to escape a predator or something like that. And so the body needed to mobilize energy quickly for the muscles to be able to escape that threat. And so what the body does when there is a perceived threat is it signals to the liver to actually dump stored glucose into the bloodstream and rapidly supply glucose to muscles. But now, very few of our threats are actually physical. Now, most of our threats are psychological, like that email or that text message or the honking or whatnot. We don't need to get up and run anywhere. We're sitting in a chair. And so we have this evolutionary mismatch now where we're constantly getting these little stress pings, and we're constantly through our cortisol and adrenergic hormones signaling to the liver to dump glucose. And that's a problem. This is our baseline state now. So it's really partially it is our responsibility to understand what tools are at our disposal to put our body into safety mode. So something like deep diaphragmatic breathing that stimulates the vagus nerve, that sends actually a chemical neurobiological signal to the body that there is not a threat. I am safe. That will change your hormonal reality. That will change your blood sugar reality. That will change your metabolic reality. And so I think even as like a stress biofeedback tool, tracking glucose has been really useful for me to see like, wow, what's causing my glucose to go up, and needing to really sit and figure out a way to tell my body through hormones that things are actually okay. So getting back to this concept of hope, there are so many levers at our disposal in our everyday life to reverse metabolic dysfunction, to optimize our metabolic health and our blood sugar. We just have to learn what they are and how to incorporate them into our lives in as simple ways as possible so that they're sustainable.
And coming back to the psychological stress piece, I think part of the problem there is that is something that is very subjective versus like diet, something that you can write down what you ate, or you could look back at the end of the day and see stress, it has ebbs and flows throughout the day, and there's so many different variables coming in and affecting that. And this is where the CGM can come in and be helpful, because you can go back and look and actually see how your blood glucose is spiking, and then try and relate that back to different times you may have gone through stress throughout the day.
That's exactly right. So continuous glucose monitors, or CGMs, are really an incredible tool because they give us, for the first time, that closed loop biofeedback on how the choices we're making are immediately impacting our metabolic physiology. So food is the most obvious one, of course, where if you eat something that causes a big blood sugar spike, that's just a prime learning opportunity to figure out, okay, what aspect of that meal spiked me? And how could I modify it next time to have less of a spike? So I've been wearing a continuous glucose monitor for 3 years now, and I'm still learning. I'm still learning new things about surprises and how to lower those spikes. And so it's really fun, to be honest. And my blood sugar data looks monumentally different than it did 3 years ago, because I've learned so many ways to modulate spikes. And we can certainly get into those more if we'd like to in the episode. But then, of course, for the stress biofeedback, I remember a few years ago that I was presenting something to my company, and I looked at my glucose data afterwards, and I hadn't eaten anything that morning, and my blood sugar went up like 30 or 40 points, which is a pretty big spike. And I was shocked. And it started, of course, the moment I started talking in that, all hands meeting. And what was so surprising to me about that was that I didn't feel stressed. It was like, I'm talking to my team. It's no big deal. I do this all the time. And so it was a wake-up call to me of, my body is perceiving stress or physiologically stressed, even when I'm not necessarily psychologically stressed. And then you think about, I was also at the time wearing a heart rate variability monitor, which is, tells you about the beat to beat variability in your heartbeat, which is a objective biomarker of stress on the body. And I noticed that my heart rate variability went down during that same period, which is a signal that you're under stress. And so to me, what that said was, I've just got to be more in tune with this and figure out, use these tools to know when I need to be doing something like a deep diaphragmatic breath, or maybe getting up and taking a quick walk, or maybe, I don't know, just like writing in my journal for 3 minutes, putting down what's going on and how I'm feeling, and building that body awareness and that interoception. Another term for body awareness of like, can you really sense what's going on inside your body? And the more we build those skills and have mindfulness about it, the more we're going to create a sense of safety in the body. So I think the CGM can be fascinating. It also, for exercise, certainly, we see that it's a lot of pro athletes and recreational athletes have been some of our biggest evangelists for levels, because they want to see exactly what's happening to their fuel and their energy substrates during their event and figure out how to optimize their fueling for their events. And so something we see is that with like more low intensity exercise, like walking or a light jog where the heart rate might be like 65% or lower, it's not really a stress signal on the body, and it's going to clear that glucose out of the bloodstream. And so we'll often see glucose kind of go down during those activities, just gently. If you do these things after a meal, you'll often see the glucose get taken up more quickly out of the bloodstream, which is great. But if you do a high intensity interval training or like a powerlifting workout, which is more of like a stressor on the body's like, oh my God, why are we running from a lion? Like, this is stressful. When in fact, you're just on the treadmill or on the basketball court or whatever. The body will send that stress hormone signal that then dumps the glucose from the liver into the bloodstream. And you might actually see a big glucose spike during like a CrossFit workout or a sprint or something like that, where you're more at like 80 to 90% of your VO2 max or max heart rate. And so the interesting thing is that type of spike is kind of one example where a spike is probably not a bad thing. And the reason for that is because when you spike during a workout, you're actually going to use the glucose. It's not like you're sitting in your chair stressed out and it's just going to sit in your bloodstream and you're going to need to release a bunch of insulin to take it up. With the workout, you're actually going to soak that glucose up. And in fact, it's kind of a good thing because you're clearing your liver of its stored glucose and pushing it through the system. You're using it. So there's a glucose sink in that situation. So it's not really as much of a problem. Additionally, muscles can take up glucose in the absence of insulin just because of the way exercise stimulates more glucose receptors to go to the membrane of the cell to take up glucose. And so you're going to be more efficient at clearing glucose from the bloodstream, and exercise improves insulin sensitivity. So that's just, I found it really fun with working out to say like, oh, if my glucose is really spiking during like a Peloton workout or something like that, I know I'm going really, really hard. And I know that I'm clearing some of that liver glucose and using it in my muscles. And then of course, after a meal, if I take more of like a power walk, I can get that real-time biofeedback that, great, that meal where I had some maybe more carbohydrates than usual, I was able to clear it out of my bloodstream more quickly because I was able to use my muscles to be a sink for some of that glucose from the meal.
I want to highlight something you just went over and make sure everybody gets that because it's so important. We live in this world where there are so many different psychological stresses, go, go, go. And you mentioned like email pings and phones ringing and things that are causing our physiology to be under stress and bombardment throughout the day. The difference between that and doing a workout is that you're not moving the muscles necessarily when it's a psychological stress. So you're causing that liver to release glucose, but it's not going to have that sink that you talked about. And also highlighting the fact that muscle doesn't need insulin and it can take glucose back in and help bring that blood glucose level down.
That's exactly right. Yeah.
One thing I'm curious about, we've talked about how at the core of all of this, our metabolism is broken, which can lead to all these different chronic health conditions. What differentiates between person to person? What area breaks? So there's broken metabolism, but there's all these different diseases, chronic health conditions that can go awry. And again, it can look like all these different things are happening in the body, even though there's a common source that relates to insulin and blood sugar. Does that primarily come from genetics, or what causes different things to break?
That is such a fascinating question, Jesse. And it's one that really gets at this concept of biochemical individuality and how symptoms and the manifestation of disease in the body is so multifactorial. It takes more than one hit. You know, it's not that there's just one thing that's going to lead to disease. It's going to be a constellation of things, of sort of where things show up in the body. But, you know, each person's complex milieu of gut function, vascular function, genetics, and anatomy, and then, of course, their level of metabolic health is really what's going to kind of lead to the ultimate manifestation of disease. But we've got this term in medicine called comorbid conditions, which is this idea that conditions often show up together. Like we see a person with obesity, diabetes, heart disease, hypertension, and fatty liver disease. These things often come together in sort of packages. And I really hate the term comorbid conditions. It's something that we're taught in medical school because it's this idea that formerly, at least what we're taught is that these just happen to all show up together. Like, oh, what a shock. Like they kind of, we happen, if you have a patient with this, you might want to look out for this. And it's like, yeah, because the physiology of why they're caused is all the same. And through your reactive lens and through the symptom lens, they all look different, of course. But through that physiology lens, they really, in so many ways, look very similar. So you're seeing a lot of these things show up in the same patient, like erectile dysfunction and prediabetes, and maybe also some depression. And it's like, yeah, well, we've got insulin resistance affecting the blood vessels. That's affecting the brain. It's affecting our liver. It's affecting our sexual organs. All these things, and so. Why it shows up in a particular organ, why one person with prediabetes gets polycystic ovarian syndrome and another person doesn't, like that's really going to come down to that biochemical individuality with genetics and history and family history and things like that. But the reality is that we see a lot of these things coming together in huge swaths of patients. But another interesting thing on biochemical individuality is that two different people are actually going to have different responses to the same food in terms of how much their blood sugar might spike. And so you and I might eat the exact same meal at the exact same time and see very different glucose responses on, let's say, a continuous glucose monitor if we were both wearing one. And this has been studied quite a bit. There's a group out of Israel at the Weizmann Institute that published a paper in the journal Cell about 5 years ago called Personalized Nutrition by Prediction of Glycemic Responses. And what they did was put continuous glucose monitors on, I think it was about 800 healthy volunteers, and they gave them all standardized meals. And what you would have thought is that, okay, well, if every meal has the same carbohydrate composition, then everyone's going to have the same blood sugar spike because it has the same amount of sugar and carbs in it. But the opposite was true. People were all across the board in terms of how much they spiked to these standardized meals, from no spike to huge monumental spikes. So then what the group did was they studied why are people different in terms of how they respond. And one of the biggest factors that they found was that microbiome composition led to these differential responses, as well as several other factors like baseline insulin sensitivity, anthropomorphic features like how much visceral fat people had, several different things. But microbiome really is a fascinating one because you think about the fact that the microbiome is really doing the first pass on all this food that we're eating. And we have more bacterial cells in our body than human cells. And these little friends of ours in our gut could not be more important in terms of dictating how we are metabolically through all the byproducts that they produce that are direct signaling molecules for our metabolism and mitochondria. Short chain fatty acids, for instance, that are produced by the microbial fermentation of fiber and polyphenols, plant polyphenols, actually go into the bloodstream, go into the cell, and can upregulate a process called mitochondrial uncoupling, which is this really interesting process whereby the mitochondria add these sort of channels, essentially, that vent excess protons and essentially waste calories. So they allow you to just dump out some of this energy and poof, it's kind of gone. And so from a weight loss perspective, that's monumental. It's essentially just wasting fuel that would otherwise go towards fat storage or ATP production or whatnot. And that process of actually venting some of this energy stimulates mitochondrial biogenesis, i.e. more mitochondria, which is, of course, a great thing for metabolism because we're more efficient. We have more of these energy factories. So this link between our microbiome and what they're eating and what's actually happening with our metabolism and our blood sugar responses is so interlinked. And of course, everyone's microbiome diversity is so unique. And so it's just fascinating to me how much of what we're seeing is really personal to us. And so what you need to do to have stable glucose and less glycemic variability may be slightly different from what I need to do. The core principles will be the same, but person to person variation should not be overlooked because and we see this a lot with our levels members, that people think they were eating something that was very, very healthy for them, but they're not seeing the results that they want in terms of their health. And then they put a continuous glucose monitor on and they realize that thing that they thought was healthy that they were eating is actually causing a huge blood sugar spike. So some examples of this might be like oatmeal. Oatmeal says heart healthy on the box. Doctors recommend it. And yet what we see is that a lot of people will eat their big bowl of oatmeal in the morning and see a huge glucose spike. I spike about 70 to 80 points when I eat a packet or 2 packets of instant rolled oats. And so if your goal is prevention of chronic disease or weight loss, a 70 to 80 point glucose spike is absolutely not working in your favor. That is not heart healthy. That's the opposite of heart healthy. That's massive glycemic variability. That's going to kick off that inflammation and that oxidative stress, take you to really unhealthy levels. But you might not respond that way to oatmeal, And for me, I just kind of gave up oatmeal completely because I don't think it even tastes that good. It's just that I thought it was healthy. So for me, it wasn't a big deal to get rid of it. But other things I could have done is, pair it with fat, protein, and fiber, add more chia and flax seeds and walnuts, maybe change the fruit on top to something that's lower glycemic, like berries. take a walk afterwards to kind of take some of the glucose out of the bloodstream. There's lots of ways, of course, to modulate the glucose spike. And I know you talked about this a lot with Jesse on your podcast, to basically, so that it's not all about elimination of these foods, but actually modulation to reduce the glucose spike. Another example are things like sweet potatoes. I get huge spikes for sweet potatoes. And again, I'm not even that big of a fan of sweet potatoes. There's a lot of other ways for me to get the healthful parts of what's in a sweet potato, like beta carotene and lots of different antioxidants and maybe a little bit of fiber. I can get those through other foods that don't spike my glucose. So for me, that's just an easy swap. I'll eat red peppers and, other things that have some of these same nutrients, vitamin C, et cetera, that don't spike my glucose. So swapping is really, very much a strategy that I employ. Rice spikes a lot of our members. So we see a lot of people switching over to cauliflower rice or eating lower portions of rice or heating their rice and then cooling it and reheating it, which creates more resistant starch, which makes it less digestible. So you see less glucose spikes. So there's just a million strategies that you can employ when you understand how you uniquely respond to a particular carbohydrate so that you can shape a diet that ideally has less glycemic variability.
You mentioned my conversation there with Jesse. I really enjoyed that and learned a lot. One of the things I really thought was great that she shared, and I'm curious if you've come across research on this, is adding vinegar, a tablespoon of vinegar to water, consuming that either before, during, or after a meal, and that having a significant impact on glucose. Because I think that's just something that is so easy for people to do, and it's relatively cheap. So is this something you do at all or advocate for other people?
This is such a fascinating question, Jesse. And the interesting thing is that there's a lot of research showing mechanistically why vinegar can help blunt glucose spikes. Acetic acid is actually an insulin sensitizer. And so there's good reason why this is possible. But we actually tested this in our levels data set. And this is one of the things that gets me so excited about the power of population data of glucose responses in helping us clarify what tools might be effective for people in terms of stabilizing glucose. So just want to give a shout out to Helena, our lead data scientist at the company, who looks at all this data of levels members in details and really shows us what's going on. So we did a challenge with members where we basically said, add or consume 1 ounce of vinegar to any meal containing carbohydrates, and then do the same meal without the vinegar and see what happens. And so they're doing this vinegar 1 ounce, which is a bit more than a tablespoon, before they eat the carbohydrate. And close to 100 people ended up doing this challenge. And what we saw was that people who did the vinegar before the carbohydrate-rich meal had much lower time out of range on their CGM data. So out of range means going above our 70 to 110 milligram per deciliter optimal range. So people who use the vinegar spent 31 minutes above range, and people who didn't use the vinegar spent 43 minutes above range. And the average glucose delta for people who used vinegar was 24.3 milligrams per deciliter, and those who didn't was 31.4 milligrams per deciliter. So there was about a almost 7-point difference in the glucose response, which actually is meaningful. That's an average. And when you think about that stacked up over several meals over the course of your life, that is a difference. There were a few people in this study who specifically ate vinegar before pizza, just a handful of them. But this one actually was very pronounced, where the median glucose delta of using vinegar before pizza was 22 milligrams per deciliter, and without the vinegar was 36.5 milligrams per deciliter. So that's more like a 14 point difference. So this is not scientific data. This is very much just real world evidence in an uncontrolled way in our data set, but it hints at some real population support to what we've seen in the research literature about the impact of vinegar on glucose response, and gets me really excited about the ways in which this type of population data is going to help us learn to eat better as a population. So that's what we found with vinegar.
Casey, you're really in an interesting position given, your position at levels and seeing all the data behind the scenes. Talk about some of the foods that people consider healthy, but they'd be surprised to learn that they cause a huge glucose spike.
Yes, definitely. So something that we've seen that has been fascinating to me amongst our data set is that many of the foods that we consider to be normal breakfast foods are actually blood glucose disasters. And when we look at some of the worst scoring foods in our data set, some of the top 20 or 30 are all cereals. So this is it's so disappointing because a lot of these cereal boxes have the Heart Healthy logo on them, which I think is one of the just biggest unethical marketing shambles that we're seeing in the grocery stores today. For instance, Honey Nut Cheerios has a Heart Healthy logo on it, and we see massive, above 40 milligram per deciliter on average glucose spikes from Honey Nut Cheerios. We also see things like Frosted Flakes, Lucky Charms, regular Cheerios, Raisin Bran, which of course is advertised as healthy. And the reason they put that Heart Healthy logo on the box is because diets, I believe that what it says in really small print underneath is that diets with like 3 grams of fiber is shows that it's better for heart health. And I think that the Honey Nut Cheerios have 1 gram of fiber. And so they're putting this on there. Of course, it also has tons of refined sugar in it, which completely counteracts this benefit. And of course, we can get huge amounts of fiber from other foods. But so cereals is a big one that has just been so obvious. These should just be taken off the shelves. Another set of things we see in breakfast category are pastries, bagels, Pop-Tarts, muffins, croissants. These are all foods that when we look at our data set, we see about a 40 milligram per deciliter or more spike. We do not want to be spiking that high. We want to stick to more like the 10 to 20 milligram per deciliter rise from baseline after a meal. So then we look at breakfast foods that actually score really well in the data set. And these are things like frittata, eggs and avocado, eggs and greens, chia pudding. We actually see this logged a lot, which is called the Fab Four smoothie. So this is a popularized smoothie recipe by nutritionist Kelly LeVeque. And it basically is a smoothie that has low glycemic fruit, a lot of protein, fiber, and fat, and lots of greens. So these things all have less than 15 milligram per deciliter glucose spike. So this type of population data shows us that there's certain foods that we've normalized that are a disaster for blood sugar, and there's a certain set of foods which are also much more nutrient dense that have much lower glucose spikes. So then we can take this data and present it to the public and say, here are some options that tend to do better across the population. And it's the first time ever, literally ever, that we've had objective data in populations of how food is affecting people's bodies in real time. And so that is power. And what my real hope and one of my missions is that this data and this population awareness of how these foods are in many cases hurting our bodies will cause a grassroots shift to push the nutrition industry and the manufactured food industry to up their game and to have better formulations, so that we're not having this type of response in our bodies, that we can no longer hide behind marketing claims anymore. Because now the actual marketing is really coming from our bodies. What is this doing to me? You don't have to believe a claim on a box anymore. You can actually find out for yourself if it works for you. Another couple examples here. So we see a ton of logs in our data set for protein bars and, different energy or meal replacement bars. And those aisles in the grocery store are always pretty funny because there's 100 options. And it's how do you choose one? And I found myself in those aisles many times, looking at the back and you're just trying to triangulate all the different, does it have seed oils? How much fiber does it have? How much sugar does it have? Is it organic? Is it not organic? And it's oh my God, what do I eat? And so now we've seen that there's some bars that spike glucose through the roof, and there's some that have virtually no glucose response. So you can actually imagine going to that aisle now with an app that tells you, okay, across a population, this had a 5 milligram per deciliter spike, and this had a 50 milligram per deciliter spike. I'm going to obviously go with the one with 5 milligrams per deciliter if the ingredients otherwise are also, quite healthy. And so we've seen, for instance, that bars that are marketed as healthy, like Cliff Bar, for instance, has one of the highest glucose spikes of any of these meal replacement power bars on the market. It actually has a higher average glucose spike than a Snickers bar. And so people are thinking they're making that healthy choice because it's got brown paper wrapping and there's a rock climber on the bar, but it's actually just like a candy bar. And then there's other bars that just virtually have no spike at all. And so that's one that I think is really empowering. And the last one I'll mention is well, could go on and on. There's so many interesting things in the data. One that I find interesting is crackers. Most crackers are made of refined carbs, and they are complete blood sugar bombs and made of white flour. And there's a couple crackers on the market that don't really spike people's blood sugar, like flaxseed crackers by Flackers. I really like Ella's Flats, which are seed crackers. There's Who Kitchen grain-free crackers. And so it's not like you can never have a cracker again if you want to keep your blood sugar stable, but there's these options that you just wouldn't necessarily know are the best options if you didn't have that data. And of course you could, look at the fiber content and all that stuff. But even then, sometimes there's some surprises that happen. And so seeing the large population data can be really, really helpful. So my goal is that someone going to the grocery store just has a whole new level of empowerment in a few years once this type of data is just really, really easily accessible. And in my mind, if the shelves at the grocery store look exactly the same in 20 years, like we will have failed. I'm really hoping that the awareness and the empowerment and the agency that comes from having your own personal biologic data and our response to food really pushes the industry forward and really pulls the rug out from under the really unethical food marketing standards that we have today.
And I think it's important to note, you talked about making a smoothie there, the specific one, and how that impacts blood sugar. We also have to consider how the food is processed. So if you're taking an apple and a banana and some greens and chewing those up in their whole form and eating them, that's going to have a different impact on your blood sugar than putting them all in a blender and pulverizing it so that fiber is no longer structurally the same.
Yeah, processing makes a big difference. There's definitely research that shows that like the more processed, for instance, a grain is, the more it's going to spike glucose. And so if we look at rolled oats versus steel cut oats versus groats, which are like the chewy whole form of the oat, there's going to be a linear progression of how much that spikes glucose based on the amount of processing there is. Because of course that processing is just making that glucose easier to absorb, faster to absorb in your bloodstream. So really, certainly the root and the foundation of good health is a largely unprocessed whole food diet. And one of the reasons why I think the diet wars are so funny is because there's so many different camps that have good outcomes, and the common link between a lot of these different diets is that it's unrefined whole foods, because that's the body does well by and large when it's given a really unprocessed, nutrient rich, set of substrates. And so one of the other things I'm very excited about with glucose monitoring is that by and large, and there are certainly exceptions to this, unprocessed food is going to have less of a glucose response. And so ideally, this type of technology would push people just naturally towards a more unrefined, unprocessed, and therefore nutrient-rich diet, which of course is table stakes for really, really good health and longevity. And I think it's also going to be interesting to see how this type of data really, really undermines the loud and aggressive diet wars, because now we have objective data showing exactly what different diets are doing to our health. And so, someone who's mostly plant-based and someone who's carnivore might both be wearing a continuous glucose monitor and both showing that it doesn't cause really any glycemic variability. Or showing in the future that their triglycerides are staying super stable and in a healthy range, and their inflammatory markers are staying in a healthy range, and their free fatty acids are looking good, and their insulin is super low. And it's like, cool. If both routes are leading you towards optimal biologic outcomes, great. Let's, stop hating on each other so much. And so more insight into really what these different dietary strategies are doing to our bodies, I think is really going to change the conversation about what is the one right path to health.
Well, I just find even in the health space, there are so many people that ignore the blood sugar piece. They'll be concerned about organic, non-GMO, or whole foods, and making so many great decisions when it comes to the diet. And again, it could be different camps, vegan, paleo, whatever it is. And I find a lot of times, and I was guilty of this as well, that's what brings people in. But within those quote unquote healthy diets, there is so much room for variability amongst the blood sugar. You can be eating and thinking you're doing something so good, but yet you're not even considering this blood glucose piece.
Yeah. And I think an example of this is like fruit. I'm very pro fruit. Fruit has beautiful thousands and thousands of phytochemicals and healthful nutrients and micronutrients in it, antioxidants. But I have found for myself, and we've also seen this in the data set, that there are certain fruits that spike me through the roof, and there are certain fruits that don't. And for me, and for most of our data set, grapes are a huge spiker. I think on average, we see that grapes have an average glucose spike of 41 milligrams per deciliter, which we don't see for all fruits. For instance, like mandarin oranges have, I think, an average glucose spike of about 21 milligrams per deciliter. And I tend to do really well with like blueberries. And I've actually found that eating less ripe fruit, so sort of a more crunchy pear as opposed to like a drippy, juicy pear, is much less of a glucose spike for me. So I tend to eat slightly less ripe apples, pears. I'll eat some small oranges, berries, kiwis. Don't have a big glucose spike. And of course, I'm often pairing these with fat, protein, and fiber, like unsweetened non-dairy yogurts, chia seeds, almond butter, flax seeds, etc., to help further blunt the glucose spike. But now I feel very confident that when I'm eating certain fruits, I'm not going on a total glucose roller coaster. Whereas with grapes, it's just huge spike up, huge spike down. I feel pretty crappy afterwards. And so within categories of food, knowing which ones work best and which ones don't really is nice, because it's not about restriction of entire food categories. It's about finding what works for you. And rice is also one that's like very much a huge staple in our diets. And, I think it's one that I think I don't want to just slam rice completely, because there are ways to eat it healthier. But for me, it just causes a huge, huge glucose spike. So something I've experimented with is like, I now make cauliflower rice sushi, and it's really easy to make. It takes 5 minutes. Like, you just microwave a bag of cauliflower rice and put some chia seeds and tahini and rice wine vinegar and just use it like you would use regular sticky rice. And when you compare, you can do this on the Levels app, you can compare 2 different responses to different things. When I look at regular sushi versus my cauliflower rice sushi, and of course the cauliflower rice sushi, I'm eating like 3 times as much because it's just all plants and, all vegetables. My spike is like through the roof in a crash with the regular sushi, and it is completely flat with the cauliflower rice sushi. So for me, that's an unlock, because I love food. I want to eat a lot of food. And so if I can eat like way more cauliflower rice sushi, that's like really great for me. So one day I want to open a cauliflower rice sushi restaurant, but now is not that time. But it really like helps you understand, like, yeah, like rice, it's not an unhealthy food, but it's not really working for my body the way it's typically put in meals. And so I can either modify it a little bit, portion size, what I pair it with, how I move after it, or I can just swap it completely and have a totally different response.
Intermittent fasting has been such a conversation in the health and wellness space for a number of years now, and for good reason. It's something I believe in and do on a regular basis. But how does that play into the whole blood sugar piece? Obviously on an acute level, we're not consuming anything that's going to spike insulin, spike the blood sugar, but it is causing that acute stress on the body. Does that ever impact blood sugar? And then over time, having that as a regular practice, how does that impact blood sugars?
Yeah. So in terms of over the long term, intermittent fasting and time restricted feeding is overall a positive for metabolic health and blood sugar. And it really gets back to all the liver stuff that we talked about before. When you are not eating and in that fasting window, your body's having to work through its circulating glucose. Then it's going to tap into its short-term glucose stores, which is the glycogen that's stored in the liver. And then once you get through that glycogen that's in the liver, the body's going to say, I still need energy, but we've kind of worked through most of the glucose. So then it starts going into your fat storage, which is our sort of long-term bank of energy that we're not going to really tap into unless insulin is low and unless you've worked through some of your stored glucose. So that's incredible. So when I'm thinking about when I'm doing a fast, I'm so motivated by this visualization in my head of like my body working through these storage depots and finally getting to that fat depot and starting to use it. And when you start using fat and train your body through fasting to intermittently tap into the fat storage, you start working those pathways, those metabolic pathways of fat oxidation and fat burning. And I think for the average American, they're really rarely, if ever, getting to that stage of where they need to tap into fat because we're constantly eating. We're eating around the clock. We're eating so much abundance of refined sugars and carbohydrates that your body never needs to use its fat, which is why 74% of Americans are overweight or obese because we are not tapping into our fat stores. So that's really what I'm thinking about. And I love also testing my ketone levels, which are byproduct of fat oxidation when I'm fasting, because I can see that as I fast and I know that my glucose, I can see on my continuous glucose monitor, it's starting to come down and my ketones are starting to come up, and watching that dance between glucose and ramping up fat oxidation is incredibly motivating. And so that, and seeing that objectively is direct evidence of metabolic flexibility, this term that we talk about a lot, which is basically saying, if you're metabolically flexible, you're someone who can bounce between burning glucose when it's available, but then also burning fat when glucose is not available. And most of us are metabolically inflexible because we're never giving the body the opportunity to go there. And when we clear out the liver of stored glucose, it's also just really a healthy opportunity for the body to not be constantly barraged by the insulin, and kind of just work through what's in there. Clear out the gunk is kind of how I'm thinking about it. So there's lots of different ways and I would say one other thing that is really coming to light through some great books like Sarah Gottfried's Women, Food, and Hormones, Steve Gundry's The Keto Code, is that the benefits that we see from like maybe a ketogenic diet or a low carb diet, you can actually, a backdoor to some of those benefits is, without having to be so restrictive, is fasting. Because what Sarah Gottfried argues is that women need more carbohydrates. And sometimes it is very stressful for the female body to be on such a low carb diet. So what does it look like to incorporate a little bit more carbohydrates and healthful carbohydrates that don't spike your glucose as much, but then use intermittent fasting and even something as simple as like a 14-hour circadian fast where you're basically just eating during daylight hours and not eating when it's dark, that actually can bump you into ketosis without actually having to restrict as much of the carbohydrates. And then Steve Gundry takes this farther with his new book, which is absolutely fascinating, which is about how those ketones, which can be produced from the fasting, or of course, in conversation with a lower carb diet, then go to the body. It's go to the mitochondria and stimulate that mitochondrial uncoupling that I was talking about, where the mitochondria actually waste calories. So ketones actually act as a signaling molecule to tell the mitochondria to vent these protons and essentially waste calories, which is one of the reasons why keto diets or diets that produce ketones, i.e. what can happen through intermittent fasting, actually help with weight loss, because they are literally causing us to waste calories and not store them. So I think there's definitely a huge role for it. And, you're giving your body a break from the insulin barrage. You're also giving your microbiome a break, which is good, letting sort of things, giving your gut lining a break. And I think the other thing that's, interesting is that eating late at night we really know more and more that that's not healthy for the body. And so that can fit in nicely with a time restricted feeding sort of strategy where you're stopping eating a little bit earlier in the night than you do normally, like 6 p.m. or 7 p.m., at least giving yourself 3 or 4 hours before your last meal and bedtime. Because we actually become a little bit more insulin resistant at night naturally. So the same meal that you eat at 8 in the morning, if you ate that at 10 p.m. at night, you're likely to have a much bigger glucose and insulin response if you eat it at 10 p.m. at night, even though it's the exact same meal. And this is for a lot of reasons. One theory is that melatonin secretion, which happens at, more at night to kind of, in part that helps make us sleepy, the melatonin may actually impact the pancreas and our insulin secretion. And so there also may be impacts on how our cells are actually sensitive to the insulin that is secreted. And so when I think about when I'm eating, I'm like, I want to get the best bang for my buck on the calories that I'm eating. So I'd prefer to eat it, in the daylight hours earlier in the day and not kind of get this unfortunate like double whammy, more glucose, more insulin if I'm eating it late at night. And when you have a spike at night, like because you're eating a late meal, a spiking crash at night, and of course it's probably going to be a bigger spike and a bigger crash, can really disrupt sleep architecture and make the sleep that we're getting less restorative, because the body responds to a big up and a big down as a stress signal. And that can actually cause arousal in the brain. And so we want to keep glucose as stable as possible, sort of as we head into bedtime, for the best sleep quality. So again, that fits nicely into sort of a time restricted feeding regimen where we're kind of wrapping up dinner a little bit earlier in the night.
So we've talked quite a bit about food, got into a lot of the nuances, but I think to come full circle, people that have tuned into this point, and again, we know we have male and female, they're going to operate differently when it comes to different foods, especially for females at different times of their life or different points in their cycle. And we're all just individuals. And with the CGMs, we're seeing how we all process food differently. What I'm getting at here is, can you give us some general principles when it comes to blood sugar, just to come again full circle on all this nuanced information that people can begin after this if they want to be more cognizant of how they're eating?
The first thing I'll say is that you don't need to be wearing a continuous glucose monitor to stabilize your glucose levels. You can use a lot of these principles, like what we're talking about today, what you and Jesse talked about, to implement them in your life. It's going to have a benefit, And so just to kind of summarize the areas that we have under our control, that we can, again, engage with or without a glucose monitor on, we're looking at optimizing food, sleep, movement, stress, our microbiomes, our exposure to environmental toxins, and our light exposure. Those are the levers that we have at our disposal to improve our metabolic health. And we've written a lot about this on the Levels blog, and so we can maybe share some articles kind of digging into each of these pillars in more detail. But I'll kind of run through each one really briefly, and a few actionable tips that people can engage with to really maximize their success with building a metabolically healthy body. So with food, one of the key things we want to think about is reducing the glucose spikes. So this is something that we can do here is pairing foods appropriately, not eating naked carbohydrates. So making sure we're pairing our carbohydrates with fat, protein, and fiber. Chia and flax are two of my favorite kind of fiber sources that you can sprinkle on top of lots of different things and get a ton of fiber in just like 2 tablespoons. You can do things like adjuncts like vinegar to reduce the glucose spikes. You can of course walk after a meal. But aside from just keeping the glucose spikes down by learning what foods spike our glucose and what the swaps that are available are, like zucchini noodles for pasta, cauliflower rice for rice, flax crackers for crackers, learning all those swaps is really important. And again, tons of information on the Levels blog about all these swaps that are better for blood sugar. You also want to think about what you have to put into the body to build the metabolically healthy machinery. So this is the micronutrients that act as lock and key cofactors for our mitochondrial machinery, our electron transport chain. These are so we want to maximize the micronutrient density of our diet. And so this is things like magnesium, zinc, manganese, vitamin C, B vitamins. They're all super critical to be able to just process energy properly. And so this just gets back to eating a nutrient-rich whole foods diet, really avoiding the processed food and getting as many nutrients as humanly possible. When I go to the grocery store, I am on a micronutrient hunt. I am thinking about how many colorful foods can I get in my cart to basically load my body with those micronutrients that are going to help my metabolic machinery. The other thing we want to be thinking about in the food category is the the microbiome, because like we've talked about, the microbiome is integral in creating metabolic byproducts that help our metabolic machinery work properly, like the short chain fatty acids. So to support the microbiome, we want to be making sure we're eating a lot of fiber. I aim for about 50 grams of fiber a day, which is far more than just what the USDA recommendation is, which is more around like, I think 28 grams for females. You want more than that. You want to give your microbiome a feast in order for them to do their job properly. And so I'm thinking about beans, legumes, nuts, seeds, even, and then of course, vegetables and fruits. But 50 grams a day. So I'm pouring a lot of beans on my salads and lentils and things like that. But aside from the fiber, we also want to eat the probiotic-rich foods, which of course the fiber feeds the microbiome, the prebiotics, but you also want to put the actual probiotics, the bacteria in the gut. And recent research suggests that actually 6 servings of fermented probiotic-rich foods per day is kind of necessary to have the optimal microbiome. Diversity, that's a lot. So most people are not eating 6 servings. This is like a quarter cup of kimchi, or I think like I forget the exact quantities in this paper, but like a half cup of yogurt, or sauerkraut, natto, things like this. And so I basically keep now in my fridge just like a whole little section of ferments, like beet sauerkraut, turmeric carrot sauerkraut, cabbage sauerkraut. I've got my super probiotic rich non-dairy unsweetened yogurts. I like Cocoa June, and I like Forager Cashew, and I like Coconut Cult. They have tons and tons of probiotics. They're organic and they don't have a bunch of crap like fillers in there. And so I'm basically putting unsweetened yogurt or fermented food on top of almost everything that I'm making at this point. And if you get a meal served by me, it's going to have a huge chunk of sauerkraut on top. Like, it tastes good with everything. Start getting used to it. It's important. So that's like the food category. Just to sum it up: fiber, micronutrient rich foods with diverse, colorful whole foods, making sure you're getting your fermented food, learning the foods that don't spike your glucose if you have a continuous glucose monitor, but even if you don't, focusing on the pairing and the making sure the meals are balanced. And the last one I'll mention that's also quite critical is the omega-3 fats, and making sure that we have healthy fats going into the body that are really important for the structural integrity of our cells that allow us to, of course, be metabolically functional. And so the omega-3s are highly correlated with metabolic health, not only because they're anti-inflammatory, and of course, inflammation has this intimate relationship with metabolic dysfunction, but also because of the way they help our cell membranes and our just general function of cell-to-cell interactions and metabolic processes. So I keep lots of omega-3 sources at the ready in my house, usually like wild-caught cans of salmon, sardines, chia seeds, walnuts. And again, I'm just like sprinkling these things on top of lots of different types of my meals. If it's a stir fry, throw some chia seeds on top. If it's a salad, throw some wild-caught salmon on top. And you're just got to make sure that you're getting a lot of these per day. So that's a lot of time on the food category, but those are some of the things that, that are easy to do that are going to help you build a metabolically healthy body.
Casey, before you move on, I want to jump in because I've heard you talk about the fact that when you started Levels, your diet was almost 100% plant-based.
Yeah.
And earlier you talked about the oatmeal factor and having a CGM and realizing how that food wasn't serving you. Basically, what I'm getting at here is I'd love for you to talk about, because you now have this data, how your diet beyond the oatmeal has pivoted over those few years.
The main way that my diet has pivoted since wearing a continuous glucose monitor is that I certainly avoid all refined sugar and added sugar in my meals, because those are just going to spike my glucose. And although I didn't eat too much of those beforehand, but I've swapped out almost everything that's a standard refined grain-based food for an alternative. So I'm really not eating many grains anymore because of what I've seen them do to my glucose, and because I've fallen in love with all the alternatives. So if I'm eating rice, it's now going to be broccoli rice or cauliflower rice, which of course gives you the other hit of fiber and sulforaphane, and which upregulates our antioxidant defenses. You're getting more bang for your buck in terms of nutrients with the cauliflower or broccoli rice, in my opinion. I'm swapping out pasta made from whole wheat or wheat flour for zucchini noodles or konjac root noodles or artichoke heart noodles, things that do not have many net carbs and which are, largely made from more whole foods. For bread, I'm now doing a lot more like almond flour bread, coconut flour bread. I make breads now. I just made an amazing bread the other day that was actually made with cauliflower rice, eggs, almond flour, and nutritional yeast. Super simple, super moist, delicious. For tortillas and wraps, I'm now using, I'll sometimes use like an almond flour wrap from Siete, but those actually do spike my glucose a little bit because they do have cassava flour in there, which is a root vegetable. But I'm using a lot of things like collard greens. I'll use butter lettuce for taco shells. I make a great flax tortilla that's just made out of flax meal that has essentially no net carbs. For crackers, I'm eating things like seed crackers, or flax crackers. So it's a lot about swaps. And so, sometimes for someone who's just eating the standard American diet, if they came over, they'd be like, what the heck are you eating? This is all just like not the actual, like you say you're eating pasta, but you're eating zucchini noodles. But I've fallen in love with that. And these things, I can now eat huge meals that just don't do anything to my blood sugar. And I'm still 95% plant-based, but it's a very different type of plant-based. And then
Have you been able to see, because again, you have your eyes on this unique set of data. I'm curious, somebody who is 100% vegan and inevitably, a lot of times they're going to consume more grains than the average person and more higher carbohydrate foods. Have you been able to see a group of these people that are on a vegan diet that are able to keep their blood sugar pretty stable?
Well, that's me. I mean, I'm eating, again, like 95 to 100%, depending on the week, vegan. And my blood sugar is generally totally flat because of everything I just said. Like it's just, you don't need to eat grains on a vegan diet. And I'm not saying grains are bad. They don't work for my blood sugar though. And so at every single category of grain, I have a swap basically, whether it's rice, bread, pasta, crackers, tortillas, there's a swap that I'm using now. And for oatmeal, it's now chia pudding, chia pudding, 0 glucose spike and way more omega-3s and fiber. Tastes, in my opinion, better. And there's no glucose spike. So it's really just like, any category there is for something plant-based. If it's fruit, I'm eating the fruits that don't spike me as much. If it's root vegetables, I'm avoiding a lot of them, but there's 1 or 2 that don't tend to spike me as high, like beets, for instance. Like, unfortunately, spaghetti squash, butternut squash, big spikes for me. Delicata squash, beets, turnips, not so much. So it's been about figuring out within categories what works best, how to pair things to not have the spike. So the apple with the almond butter and the chia seeds and or the chia pudding. And then within categories that are largely refined grains or grains, what are the swaps that are more usually based in vegetables, nuts, or seeds that I'm swapping things for. So I think it's totally doable. I think that this actually has the opportunity to really help people clean up their vegan diets because there's a lot of people who are on a plant-based diet that it's unfortunately largely based in processed or grain-based foods, and they're not getting the outcomes or the results they want. And so this is a way to really get some insight into how to modulate things. I think it's super interesting. Like right now, 50% of American adults are on a diet each year. 50% of American adults are reporting in a survey that they're trying to lose weight and going on a diet. And of course, the outcomes are abysmal. We're getting heavier every single year. And most people who even have success on a diet gain it back within about a year. And so we have this massive, monumental effort outcome mismatch in our country where the effort's there and the outcomes are not. And I think one of the key ways to sort of improve that mismatch is through objective data that shows you what's actually happening with the choices that you're making, because people are trying to make good choices. They really are. I've had so many patients come to my office and say, I'm trying so hard. I've switched so many things in my diet and they're not getting the outcomes they want. And I think part of this is because the things they're choosing are not actually working for their unique physiology. And now, for the first time, we at least have some insight into that. I mean, glucose is not the only biomarker that matters for an optimal diet, but it's a really important one. And so we've seen a lot of our members have much more rapid success with using a glucose monitor. It's certainly not yet a weight loss tool. Like we'll need to show a lot more data to see if that's consistent across a population. But anecdotally, there's been some really amazing success stories based in things like what we've talked about, where people have been eating things they thought were healthy for them and actually found that they're really keeping their glucose quite high. I did a podcast with one of our members, Betsy McLaughlin, who's an amazing woman, executive on a bunch of boards, former CEO of Hot Topic. And she'd been trying to lose weight for like 30 years and had spent, hundreds of thousands of dollars on support from nutritionists and doctors and, all sorts of people. She put on a CGM and she lost like almost 100 pounds in about a year. And it's because she basically just like eliminated every single thing that was spiking her glucose, and her insulin levels dropped from like 30 to 5. Her fasting glucose, of course, plummeted. Her liver function tests improved, all these things. And so it's not a panacea. I'm not, trying to say that, but it's wonderful to see that people who are already trying might have a little bit extra personalization and support and feedback in whether what they're trying is working for their bodies.
So Casey, before we part ways with food, there is other things I want to make sure we cover before we part ways. Can you give us the highlight bullet points when it comes to food and blood glucose?
Great question. So when we're thinking about how to build a metabolically healthy body, there's really 6 things that we want to be thinking about. We want to be thinking about what foods do not spike our glucose levels and keep us more stable, and emphasize those in our diets. We want to be thinking about how many micronutrients we can get into our body so that we can have all those little cofactors that help our metabolic machinery run smoothly. We want to have a fiber-rich diet that supports our microbiome. We want to include fermented, probiotic-rich foods that also support our microbial diversity. We want to get lots of omega-3s, which support our cell membrane integrity and our anti-inflammatory status. And we want to also be thinking about organic. And the reason for that is that glyphosate and other pesticides can actually be mitochondrial disruptors and can hurt our mitochondria. And also, food that's grown organically is going to have a higher micronutrient composition. And so that's, of course, going to be good for our metabolic pathways.
Casey, you keep hitting on this micronutrient piece, and I'm curious, as you're saying that, you talked about going to the grocery store and trying to get as many micronutrients, and I'm the same way. But is it doable with just food, or do you like to take supplements to accentuate that?
Great question. Food is the foundation. We need to be starting with getting as much micronutrient dense food as we can through what we're eating every day. Again, 3 pounds of food per day, every calorie an opportunity to maximize micronutrient density and nutrient density in general. So that's how I'm really thinking about my day. I'm like, I have all these opportunities to put this matter, this energetic substrate, this molecular information into my body to build the body, to become my biologic reality. How am I going to maximize what's going in today? With that said, our food is more micronutrient deplete than ever because of our poor soil quality. Because of the way we've done monocropping agriculture, the way we've overused pesticides and antibiotics in our water and in our agricultural practices, we have completely destroyed the microbial diversity of our soil. And so the food that we're eating actually is significantly less nutrient dense than it was before. So I'm not confident that even eating like a perfect organic whole foods diet is going to give you every single piece of molecular information that you need. And so I actually do supplement quite a bit. And I do my supplement my supplement regimen in a very precision way by doing a functional medicine test called Genova's Nutraval test, which looks at lots of different metabolites in the body that can give you a sense of where you might be low on particular micronutrients. There's also a test that I've done through Everlywell and Let's Get Checked. Both have micronutrient tests, so you can see a few of the micronutrients like B vitamins and vitamin D. And these can help you understand like how much of a supplement you should be taking and for how long. And you should be testing these things regularly to make sure you're not overshooting. But the average American is deficient in at least one key vitamin or mineral. And so we really do need to be thinking about this because it is hard to get everything you need from food given the way that food is raised today. But the key ones that we really need to be thinking about for metabolic health are vitamin C, vitamin D, magnesium, B vitamins, manganese, selenium, zinc. There's many others, but those are some of the key ones that are really important for our metabolic machinery.
So when it comes to that handful you just named, would it be a multivitamin you take to get all those in one, or you have kind of separate supplements, or you look to certain foods to get those almost as a supplement?
I definitely look at foods as a way to almost supplement intentionally. So for instance, and this is something that I think everyone can really benefit from becoming familiar with which foods have high levels of which micronutrients. So I actually look at pumpkin seeds and I think magnesium. And sometimes some of my friends will make fun of me because I'll actually sometimes say I want to put magnesium seeds on this. And so I've literally like brainwashed myself to think a pumpkin seed is a magnesium source. Same thing with Brazil nuts. Those are obviously a key selenium source. When we're looking at pistachios, they have high levels of melatonin. When I'm looking at flax seeds or chia seeds, I'm thinking about omega-3s and potassium. So really just thinking about what foods have which micronutrients, red peppers and oranges, vitamin C, and becoming familiar with that. And then you can start to use food as almost like a supplement and knowing that, okay, if I get like a quarter cup of pumpkin seeds, I'm going to get like my daily needed amount of magnesium. And like shellfish has a lot of zinc. And so just looking up online, like what are the sources of these key micronutrients and making sure you're emphasizing those foods. It also makes eating a lot more fun because you're trying to build diversity of what information is going into your body by understanding these different things.
I like that. And Casey, before I let you go, I know there's a whole bunch of different pillars when it comes to metabolic health we haven't gone deep into. We went really deep into the food piece, and that's the foundation. They're all foundational. I don't want to minimize any of them, but that is the staple piece that people can begin to make changes in today. So I'm glad we went deep into that. What I'd like to do, if you're good with this, is quickly go through what the other pillars are, or at least a handful of them, and get into some of the more important points there. And then maybe we can have a round two down the line, basically steer mostly away from food because we've covered that so deeply, and get into all these other pillars because they are so important. I want to make sure we do justice. But before we part ways, can we just get a little tidbit of these different pillars and the highlights of each?
Sure, absolutely. I'll just list them and maybe one actionable tip that people can do to help optimize metabolic health. So we talked about food in depth. The next one would be sleep. Aim for 7 or 8 hours per night. In epidemiologic studies, this seems to be the key amount that we need for optimal metabolic health. We want to try and have as much consistency in sleep as possible. So that means going to bed and getting up at the same period of time because that really feeds into our circadian rhythms, which actually define some of our metabolic processes. Our bodies kind of work on a biologic clock. And so we want to sleep and eat ideally in as regular windows as possible. This is the one I'm absolutely the worst at. I bounce around all the time on what time I go to bed. But unfortunately, I do see it on my continuous glucose monitor. So when I go to bed late, I'm going to see usually higher glucose levels the next day. Sleep deprivation increases our cortisol levels, and it also it disturbs our satiety hormones. So we actually often will crave more carbohydrate-rich foods because of the way sleep impacts our ghrelin and our leptin levels. So when you're sleeping, you're investing in less cravings the next day, which I think is really powerful. And there's one last tidbit on sleep. You can take a group of healthy non-diabetic individuals and sleep deprive them for 6 days, give them just 4 hours of sleep per night, and you can turn them into people with prediabetes. So it is just a small amount of sleep deprivation that can totally perturb your insulin sensitivity. In that particular study that I'm talking about, they then gave them as much sleep as they wanted after that intervention. And of course, things, bounced back and got better, but you don't want to be putting your body under that type of stress. So that's sleep. The next one is exercise. The key things I'd say about exercise is that movement is critical for optimal metabolic health, because when we're moving our muscles, we're creating a glucose sink and we're moving more glucose channels to the receptors of our cells to take that glucose out of the bloodstream and process it. Exercise also improves mitochondrial biogenesis. So we're actually getting more of these energy factors to process that glucose. All different types of exercise have been studied. And it would be way too simplistic to say there's one particular type of exercise that's optimal for metabolic health, because yoga, zone 2 low intensity training, high intensity interval training, resistance training, and walking have all been extensively studied, and they all help. So it's kind of like do something at a bare minimum. And maybe in another episode, we can go deep into like each of those types of exercise and what we know about how it affects mitochondrial health and mitochondrial capacity, because it's really fascinating. But the key takeaway I'd say is, if you can do one thing differently in your life, it's incorporate more movement throughout the day. So not just focusing on one workout at the end of the day, which is great if you're doing that, but actually trying to do 2 minutes of physical activity every 30 minutes throughout the day. Because in research, they've shown that if you have people just even walk or jog for 1 minute and 40 seconds to 2 minutes every half hour, they have lower 24-hour glucose and insulin levels than people who walk the exact same amount of time, but in one chunk at the end of the day. So I keep a kettlebell right next to me in my office. I have a treadmill desk usually underneath this desk. And so that's been a big unlock for me studying this research, is that it's moving more frequently that is really, really useful. Our bodies are intended to move. They're not intended to sit for 14 hours a day. And the way I see it is it's kind of use it or lose it. If these pathways are inactive all day, except for 30 minutes or an hour, they're kind of just like, it's all just atrophying during the day. You want to, even if you're just sparking it for 1 minute or 2 minutes, you're still keeping all those pathways active. So move more during the day. It can be super low intensity. Just do something, few air squats, dance around your office, kettlebell, walk around your house. So the next pillars we've covered now: food, sleep, exercise, is stress. We've talked extensively about stress in this episode. So I think the key takeaway I would say is more deep diaphragmatic breaths. And what I mean by diaphragmatic breaths is a breath where you're breathing in and your belly goes out, because your diaphragm, which is the muscle that goes down when your lungs inhale, is like pushing the belly down, and you want to see your belly expand. The reason that's important is because the diaphragm is connected to the vagus nerve. And the vagus nerve is really this nerve of relaxation, the nerve of parasympathetic nervous activity, the nerve that's going to release the hormones that tell your body that you're safe. So when you're breathing in, flattening that diaphragm, expanding the belly, stimulating the vagus nerve, you're literally giving your body a neurochemical signal that your body is safe. And that's going to, of course, feed into that downstream cortisol and the sort of threat signaling that ultimately is going to keep our blood sugar elevated. The next one is microbiome. We've also talked about this quite extensively. So the key points here are making sure you're getting the multiple servings of probiotic-rich food per day, making sure you're getting the prebiotic food, so like the actual fiber. I aim for 50 grams a day. Making sure you're getting colorful diversity of plants. So the American Gut Project recently showed that people who got more than 30 different types of plants per week had better microbiome diversity than people who had less than 30. Less than 10 in that study. So it was kind of looking at people with less than 10 or more than 30. Above 30 was really the magic number for having the better population. So I would implore you to, in this coming week, count how many different types of fruits, vegetables, nuts, seeds, beans, types you're getting per week, and aim for 30. It's really not hard. I'm now shooting to get above 20 in a single meal. And if you start doing that, I mean, it's like a field day for your gut. So probiotics, prebiotics, diversity, and then take out the stuff that hurts the microbiome. So this is the pesticides. This is the refined grains and the refined sugars. These are the things. And then one other thing is excess antibiotics, of course, and excess pain relievers like Advil. So NSAIDs, nonsteroidal anti-inflammatory medications, of which Advil is one, these can actually cause problems with our microbiome. And of course, excess antibiotics is going to kill a lot of the microbiome. And so if antibiotics you need them for a bacterial infection, of course, take them, but we're way overusing them right now. We're both overusing anti-inflammatory medications and antibiotics. So limit them if you can. And then the last couple to talk about is environmental toxins and light exposure. And I'll run through those really quickly. With environmental toxins, we're thinking about things that either are disrupting the microbiome, like I said, so things that are going in and hurting our beautiful gut bacteria that do so much for our metabolic health, but also things that are disrupting our actual mitochondrial function and causing damage to our energy factories. There's a fascinating paper that came out just a couple months ago. One of our advisors, Dr. Rob Lustig, who's been on your podcast, was a lead author on this paper. And it was about obesogens, which are a class of environmental chemicals now that we know directly lead to obesity. So it used to be that there was a correlation between toxins and obesity, and we now know mechanistically that these are actually causing obesity in part because of what they're doing to our mitochondria. The crazy thing is that these obesogens, which are a type of endocrine disrupting environmental chemical, these are largely industrial chemicals that are basically unregulated. They have very little oversight. You can create something for an industrial product and put it in your product and kind of do it willy-nilly. This is insane. So stuff that obesogens are in, personal care products, makeup, deodorant, shampoo, conditioner, home care products, our cleaning sprays, our dish soap, our laundry detergent. It's in our mattresses, our furniture, our electronics. It's in the ink that's on the receipts we get from the store. It's in car exhaust. It's in our air. It's in our water. It's in the fragrance in our candles. It's everywhere. We're talking about hundreds of chemicals. It's in plastics, plasticizers, clothes. Polyester is plastic. And now, of course, we're seeing polyester in microplastics in our food and our water, and then it's pesticides. So clean living, gosh, this could be a whole nother episode, but figuring out ways to avoid as many of these as possible is so important. So that could be filtering your air, filtering your water, organic food, knowing your farmer, trying to buy non-toxic materials, organic cotton, organic bamboo, clothing, etc. And then the last one is light. Light is so interesting because while food is molecular information that goes into the body, light is energetic information that goes into the body. And so you really think about light almost as food in a different way because it's stimulating your body in as direct of a way as food. And so when light goes into your retina and hits your photoreceptor cells in the retina, it's sending a signal to this part of your brain called the suprachiasmatic nucleus. And that's really the top-down control over the clock genes in the body that set up how a lot of our core processing in the body unfold throughout the day. So if you're having erratic, what's called sometimes in the science, erratic photic signals, so basically light at times that we weren't normally supposed to get light during the day, like at night, for instance, through blue light and through our computers, it's totally confusing those clock genes in the body and that circadian rhythm of the body and can have an impact on our metabolism. So we want to be getting, practically speaking, wake up, first thing you do, go outside and look at the sky for a few minutes, 2 minutes. What I usually do is when I'm brushing my teeth in the morning, I always open the door and stand outside when I'm doing it. And I stare at the sky, no sunglasses. Get that light that says to your body, it is morning. For so many of us working at home now, you might not go outside until mid-afternoon. And so, and the light that comes to the windows is not even close to as strong as what you get from direct sunlight. So you want to go outside, look at the sun, tell the body it's morning. And then ideally towards the end of the day, move away from your devices, but that's really impractical for most of us. So, wear the red orange tinted glasses to hopefully block some of the blue light starting after dinner or so. You don't want to necessarily wear the blue light blocking glasses throughout the whole day because you want your body to know it's daytime during the day. But as you move towards nighttime, if you're going to be looking at your screens, have some blue light blocking glasses. So light is actually one that is so overlooked. That's really quite important. And people who are exposed to blue light late at night have worse metabolic outcomes. This is another one that I'm actively working on in my life right now. But so that's kind of the overview: food, sleep, exercise, stress, microbiome, environmental toxins, and light exposure that are our actionable levers to improve our metabolic health and really speak to how holistic this is. It's not one thing that I think is missing in sometimes the conversation about metabolic health is that we get in this mindset, or we hear this mindset, that just by going low carb will make you metabolically healthy. But I think what we've sort of seen as we've talked through all these different levers of metabolic health is that it is so much more complex than that. You can't build a metabolically healthy body by removing just one micronutrient. You have to build a metabolically healthy body by tapping into all the different levers of metabolic health consistently, day in and day out, to really foundationally build sort of a structurally and functionally sound system. And so while low carb can be a thread of a comprehensive strategy, it never is going to be the one thing that builds an optimally functioning machine.
Final point to end on, Casey. Somebody who's listening or tuning in right now and they say, I'm a metabolic mess. I'm not doing any of these things you talked about, but I am going to make the shift. And kudos to you for doing that, person out there who's ready to make the shift. I'm happy for you. But how long does it take when people start to move some of these big levers? How long does it take before their metabolic health starts to pick up some inertia?
It can be days. It can be almost instant. I've seen patients, for instance, drop their triglyceride levels by 100 points in 1 month just by eliminating refined sugars and grains and adding in more whole foods. So this can be very rapid and very motivating to see some of these biomarkers shift really quickly. And if you're wearing a continuous glucose monitor, you might see very quickly that as you make some of these changes, the extent of your excursions, of your spikes, starts going down a little bit. And then if you're able to achieve that minimization of spikes over time, may start seeing your fasting glucose go down as insulin sensitivity starts picking up a little bit more. And so I think really quickly, but for people who are, like you said, more down the spectrum of metabolic dysfunction, probably more mitochondrial damage, you have to think about that you're rehabilitating these little systems in our cells. And so that can take longer if there's more damage. But I would just orient around what's every single possible thing I can do to support this amazing little part of my cell. There's thousands of mitochondria in every cell generally, but to really just make it happy and healthy. And you will see things start to improve as these little machines kind of get back online. But it is a rehabilitation process, right? So one thing I like about testing certain biomarkers like triglycerides or glucose or insulin is that you can start to see those changes relatively quickly, and that can be quite motivating. So
for somebody that is interested in using a CGM as a tool to repair their metabolic health, I know in the past levels had a wait list and things were unrolling over time. Where are you guys at with that right now? Can people go and join the program at this time, or is there a wait list? What does that look like?
Yeah, so we're actually right in the middle of our launch right now in June. And probably by the time this episode is aired, if it's airing end of June or early July, everyone will be able to just go to the website and buy the product. So we're rolling that out right now, recording in early June. But as of about July 1st, anyone can go to the levelshealth.com website and sign up to get continuous glucose monitoring access.
Amazing. Casey, I love this conversation. We went really deep, covered a lot. I've become inspired in a lot of different areas, hearing you talk about the science, hearing you talk about the way you live your lifestyle. It's just incredible. So I'm definitely going to want to go back and listen to this again and pull out some more of the tidbits that we discussed. And I just want to thank you for doing the work you've done and making the pivot in your career, which I hope we can get into next time, talking about making that big leap from being a surgeon to working in starting levels. And that's just incredible. You're following your passion. You're helping so many people. And thank you for coming on the show.
Thank you so much, Jesse. And thank you for the incredible work that you are doing, getting this information from all of your guests out into the world. It's had a huge impact on me over the years, and I know millions of people. So thank you so, so, so much.
Stick around and watch my interview with Jesse and Chousby next. We go deep into how to balance your blood sugar.
90% of the population has glucose spikes every day without knowing it. And so I dove into the research and I discovered that actually there were things I could do, principles I could use that would allow me to avoid glucose spikes.